Okay, we're going to be looking at problem number 8, WebAssign chapter 27, current and resistance. The objective is to find the lengths LC of carbon and L sub Ni of nichrome such that the overall temperature coefficient is 0. And that is the question. So how do we start this? Well, we need to find some combination of the two, and we have two unknowns. We have LC and LNI. So somehow we have to obtain two equations relating LC and LNI. So what are the conditions? Well, the first condition is, and I'll give you a chance to answer that RC plus RNI is equal to a constant, whether it's 10 ohms, 15 ohms, 14 ohms. The whole idea is that RC and RNI is constant. And the second condition is that RC at any temperature plus Rn at any temperature is the same constant. Now, what is the temperature dependence of each section? Okay, RC of T and Rn of T. How does each section depend on temperature, or the resistance of each section? I'll give you a moment to write that down. Of course, RC of T is RC times 1 plus alpha C, the temperature coefficient, times T minus T0, where T0 is a reference temperature, and Rni of T is equal to Rni times 1 plus alpha Ni, the temperature coefficient, times the temperature minus T0, the reference. Now, what is this quantity I show below? This sum of RC times its temperature dependence plus Rni times its temperature dependence. Take a moment and just think about it and write it down, and then continue the video. Well, that's got to also equal RC plus Rni. Remember, I said it was constant. Okay, it's the same constant. Now go ahead and take a few minutes and show that the equation above, number 4, RC times its temperature dependence plus Rni times its temperature dependence is equal to RC plus Rni, and show that it leads to RC alpha C plus Rni alpha Ni equal 0. Pause the video and work it out. Now, how is RC and Rni related to their resistivity? Okay, once again, pause the video. And of course, RC is the resistivity of carbon times the length of carbon over the area, and the resistance of nichrome is the resistivity of nichrome times the length of nichrome divided by the area. What does equation 5 become in terms of resistivity? Pause the video and work it out. And of course, that's rho C LC over A alpha C plus the rho Ni Lni over A alpha Ni equals 0. And what about 2A? What does it become in terms of resistivity? Pause and work it out. Then continue. And of course, that is that the resistivity times the length over the area of carbon plus the resistivity of nichrome times the length of nichrome over area must be equal to that constant C. Now you have two equations and two unknowns. Go ahead and complete the solution. and end of discussion.